Welcome to the Noisy Composer. All right, part 6 on our journey of Audacity. Today what I'd like to work on is phase issues. And so before we get into our practical application, exploring Audacity and looking at our drum sounds and how phase cancellation would affect our drums, first what I'd like to do is some theory. So what is phase? Phase is defined as a particular point in the cycle of a waveform. And it's usually measured in 360 degrees. We cannot hear the measurement, but it's useful as far as how it relates to other waveforms. So phase, summation, or cancellation is how two waveforms interact with each other. Now in the real world, it's a lot more complex, but electronically we can easily demonstrate how it works. All right, let's look at our example. This program is called Max MSP. I have a cycle wave, which is basically, I've labeled this for you, sine wave object. So we can hear it. Let's turn it up a little bit. Okay, and so therefore we're listening to a sine wave. And notice when I turn it up, we can see the amplitude, the loudness. Okay, so I want to set that at -6 dB, and it fits nicely into our scope here. Now, as far as the measurement of the sine wave, we can plot the location or the phase by looking at, let's say the center line is 0 degrees. So this waveform, the full cycle goes positive, back to 0, negative, and there. That's a full wavelength. So we can look at it as 0 degrees, and then 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So that would be the full cycle of a waveform. Now you think of them in relation to others. So therefore, what we have is here's one sine wave that we're listening to. Here's a second one that I'm going to introduce, and the relationship or the mix of these two outputting to this third scope. So right now we only have one sine wave going, so therefore they're an exact copy of each other. Let's bring in the second waveform. So the volume, it gets louder. Let me turn down the output. So therefore we can see that if both of these, this first waveform is at -6 dB, the second waveform at -6 dB, the summation or the addition of these two together create this composite wave, which is then all the way full. So next thing, we can now change the phase of it. So let me reset it. And we can see that right now, this first waveform and the second waveform are in phase together. The peaks are aligned. The valleys are aligned, and therefore in the composite wave, the peaks are aligned and the valleys are aligned. Now, if I change the phase of the first one, I have presets, but I'll just roll it for you. You can see that it's moving, okay? So the waveform's moving, and you can also see that the position of the phase of the first waveform in relation to the second waveform changes the composite or the outcome. So therefore, if we start at 0 phase, they're in phase together, and this is full volume. If we're in 0.5, I have a chart here, which is 180 degrees, you can see that these peaks are completely opposite from each other. So therefore, the output of sine wave 1 and against sine wave 2 cancels each other out. Okay, let's turn this up so we can hear it. So in phase sounds like this. And then out of phase, 90 degrees, a little less volume. Let's double check that. Full volume, a little bit less volume, and then 180 degrees out of phase, fully cancels each other out. Back to 270 degrees, it's a lower volume, and back to 360 degrees, full volume. So we can see, so what we can see is that when phases are aligned, the two waveforms add together to create a louder waveform. If the two waveforms are out of phase with each other, then they cancel each other out and we don't hear those. Now, it doesn't necessarily work like that in the real world. It's not an all or none situation. Usually what happens is that every sound has a complex collection of waveforms, and therefore the lower ones are fighting with each other. So when you're listening to, say, a drum set, you're mixing a drum set, you have two microphones, right? Because they're in relation to each other. One microphone's on the kick drum and the other one's on the overheads. So when you turn up the kick drum, it should sound full. And when you turn on the overheads and you mix it in, it should sound fuller. But when you bring in the overheads and it seems like you've lost something, you've lost the power or punch of that kick drum, or it's not as bassy or boomy as you think it should be, it's probably out of phase. All right, let's go to Audacity and see what this sounds like in the real world. All right, so we're in Audacity, and what I'd like to do is to look at the kick drum in relation to the overheads and see if they are in phase. All right, so we're gonna quickly listen. Okay, we'll select kick drums, zoom in here. Okay, let's select one. Okay, and what you see is right here, it's when it's negative, this one's positive. So they are out of phase with each other. So what we can do is we can select the overheads. We can go to Effect, go to Invert, and select it. And in Audacity, it immediately inverts the waveform. Okay, so now these are pretty subtle, so you may not be able to hear it, but maybe our meters will tell us if it's gotten louder or softer. So let's listen. I'm looking at the meter here. It's like -3 dB. Okay, let's go back. Let's undo our invert and see what that sounds like. So now they're out of phase again. Here we go. Out of phase, -6 dB. Okay, let's put it back in phase. They're in phase again. So out of phase, -6 dB. In phase, -3 dB. Let's look. Louder. In other DAWs, there are more meters that will help us analyze phase. But I think we were able to do pretty good in Audacity and quickly find something that's out of phase, invert it, and we can see by the output that it's actually louder. So we've done good here. All right, high five, have a great day.